Hi everyone, welcome to another video lesson, and this video lesson will conclude this notes packet. Okay, so real quick, standard form quadratic, which is what we're working with today. We have been working with this formula for the whole unit. So this one gives you the y-intercept, but when you factor it out, you can also determine the x-intercepts. Okay, so we're just doing factoring for now, but on the next unit, I'm going to teach how to solve quadratic equations. Don't forget, vertex form gives you the vertex. So if you know how to factor a standard form quadratic, even though you have to check it's factorable, because there are some that are not factorable. But if it's factorable, then if you have it in vertex form, you have the vertex point. If you have it in standard form, you have the y-intercept. And then when you factor it out, you also get the x-intercept. So that gives you either gives you the vertex, the y-intercept, and then if it's factorable and the solutions are real numbers, then that gives you the roots, the real roots. Okay. All right. So to that end, let's continue and finish up this notes packet. So example number 1, is there a GCF? The question is, does 8 go into 162? And yes, it does. The GCF is 2. Okay. So I'm going to factor that out right away. So then this 8 becomes a 4x squared, and instead of negative 62, that changes to minus 81. Then from here, I'm going to ask the next question, is this a difference of squares? Well, we know 4 is a perfect square and 81 is a perfect square, and this is x squared. So the answer is yes. Since it's a difference of squares, then we can apply the formula that you have on the previous page. So then this factors as 2x minus 9 times 2x plus 9. And again, if you don't remember this, go back to the last lesson, which is where I explained this in detail. Okay, so we're done factoring. Second example, is there a GCF? Does 2 go into 49 and 25? The answer is no, so there's no GCF. And obviously this is a three-term trinomial, so this is a three-term polynomial, which means, and we also look for the value of a. Since a is 2 and not 1 and there is no GCF, then this one we have to factor by grouping, which means we need to split up the middle term. So to split up the middle term, let's find the multiples of, okay, a times c. A is 2 and c is negative 25. So multiples of 2 times negative 25, which is negative 50. And then from those multiples, choose the ones that when we add them, they add to our b value, which in this case is a 49. Okay, well, that's simple because when you multiply 1 times 50, that gives you 50. And notice we need to multiply them to a negative 50, so that means you got to have opposite signs. And since when we add them, we end up with a 49, it only makes sense that the 1 gets the minus. Okay, so then I'm going to split up 49x into 50x and negative 1x. So then 2x squared minus 50x plus 50x minus 1x minus 25. Then group them. So there's one group and there's a second group. So we do the GCF twice. So GCF of this group is 2x and GCF of this group is negative 1 because of that negative lead. So then factoring out 2x from this group, we have 2x as a GCF, and then this becomes x, and 50x divided by 2x is 25. And then factoring out a negative 1 as a GCF on the second group, then this x becomes positive x, and that 25 switches to positive 25. Then we have x plus 25 and x plus 25, which means we can factor that out as a GCF on the two groups, and then put together 2x minus 1 in another parentheses. So 2x minus 1, and this is factored completely. Okay? So I hope this is not too bad. You're seeing it for the, I don't know, we've done this packet. It's all about factoring from GCF to binomials, trinomials, four-term polynomials, so on and so forth. Okay, last example. The last example says a square has an area of x squared plus 4x plus 4. Express a perimeter in terms of x. So let me sketch real quick a square. Okay, let's assume that's a square. We know that in the square, all sides are equal. So that's what we care about, the square. Not so much about the angles. Okay, since all sides are equal, and notice the value of a in this case is 1. So since a is 1, this is simple factoring, and there's no GCF here. So then let's find the multiples of a times c, a being 1 and c being 4. So 1 times 4 is 4. So find the multiples of 4. that when we add those multiples, they add to our b value of 4. Well, that's simple, because when you multiply 2 times 2, that gives you 4. And when you add 2 and 2, that gives you 4. Therefore, this factors like this. So x plus 2 times x plus 2. Since all sides are equal on the square, then each side is x plus 2. And to find the perimeter, because that's what we need to find. Okay, find the perimeter in terms of x. Then all we need to do is add the x's, or you can also follow this formula. So perimeter equals 4s. Okay, with s being each side of the perimeter. So then since each side is x plus 2, so then the perimeter equals 4 times x plus 2. Then distribute. So the perimeter equals 4 times x is 4x, and 4 times 2 is 8. So this is the perimeter of that square. So I hope this is not too bad, but if you have any questions about this, I'll see you in the classroom and I'll answer those questions. Thank you for watching. Bye-bye.